Welcome back to the podcast. Today we're diving into the fascinating world of data systems and their evolving landscape. We're focusing building reliable, scalable, and maintainable data-intensive applications. Whether you're a seasoned data engineer or just starting your journey, these concepts are vital for navigating the complexities of modern data systems. So, grab your headphones and let's get started. Let's start with some foundational terminology that's essential for anyone working with data systems. Here, we explore key concepts like reliability, scalability, and maintainability. Reliability is about ensuring that your system performs consistently over time. It goes beyond just having a backup plan. It's about designing your system to minimize downtime and data loss. Scalability, on the other hand, refers to your system's capacity to handle increased loads, whether that's more users, more data, or more transactions. Finally, maintainability focuses on how easy it is to update and manage your system over time. Achieving these goals requires a thoughtful approach to system design. It's not just about throwing more hardware at a problem. You need to consider how your architecture will evolve as your application grows. Next, we dive into the various data models and query languages available today. How different data models, like relational, document, key value, and graph, are suited for different applications. For instance, if you're dealing with complex relationships, a graph database might be your best bet. On the flip side, if you need flexibility in your schema, a document store could be the way to go. Few videos will also discuss query languages, such as SQL for relational databases and more specialized languages for NoSQL systems. Understanding the strengths and limitations of these models and languages is crucial for selecting the right tools for your specific needs. Then, we take a closer look at storage engine internals. Some podcast sessions delves into how data layout can significantly impact performance. Sessions explains that choosing the right storage engine isn't just a technical detail. It can make or break your application's performance. Different engines optimize for different workloads, and understanding these nuances can help you make informed decisions. For example, some engines might excel at read-heavy workloads, while others are optimized for writes. The videos also touches on the importance of indexing and how it can speed up data retrieval. However, it's a balancing act. Too many indexes can actually slow down write operations. This nuanced understanding of storage engines is essential for anyone looking to optimize their data systems. Finally, we examine data encoding formats. In a world where application requirements are constantly evolving, the ability to adapt your data schema is more important than ever. The videos discusses various encoding formats, such as JSON, Avro, and protocol buffers, and how they can facilitate schema evolution. This is particularly relevant in microservices architectures, where different services might evolve at different rates. The chapter emphasizes that choosing the right encoding format can significantly impact how easily your application can adapt to changes. As your application grows, being able to evolve your data schema without breaking existing functionality is a key consideration. As we wrap up our discussion, it's essential to highlight a significant trend in modern application development. There's a noticeable shift toward data-intensive needs rather than compute-intensive ones. This means that as applications become more complex, they often require a combination of tools like databases, caches, and message queues to handle their data needs effectively. The podcast notes that this has led to the creation of composite data systems, which integrate multiple data sources and tools to provide a seamless experience. As we move into an era where data is at the forefront of application design, understanding how to integrate these various systems becomes paramount. The challenges of ensuring performance and reliability across different data systems are significant, but the insights from this podcast provide a solid foundation for tackling these issues. To put this all into perspective, the videos provide some historical context. In the past, hardware redundancy was often sufficient for most applications, allowing for quick recovery from machine failures with minimal downtime. However, as data volumes and computing demands have surged, many applications now require multiple machines to operate effectively. This shift has led to a higher incidence of hardware faults, especially in cloud environments like AWS, where virtual machine availability can be unpredictable. The focus has shifted from relying solely on single machine reliability to designing systems that are inherently resilient and capable of handling failures gracefully. We've covered foundational concepts, explored various data models and storage engines, and discussed the importance of data encoding formats in an ever-changing landscape. As we continue to navigate the complexities of data-intensive applications, understanding these principles will be crucial for building systems that are not only functional, but also resilient and adaptable. Thanks for tuning in today. If you enjoyed this episode, be sure to subscribe for more discussions on data systems and technology. Until next time, keep exploring, keep learning, and keep building.